In lesson 2, we're going to look at more ways to represent functions. So in the first lesson, we really talked about the definition of a function, understanding what it means. So basically a function, if you remember from the first lesson, is any type of relationship where each input only has one output, exactly one output. So each input only goes to one thing. So when we look at these different ways to represent functions, you can also represent relations using these same methods that we're going to look at. And when we look at these, though, we want to talk about, well, what makes this kind of relationship a function? So whenever we have equations, basically any equation is going to be a relation because it's going to show you how x and y are related. So for example, y equals 3x plus 2. If I plug in any x value, any input, the output I get out, these two are going to be related such that plugging in, or x is 3 times plus 2 to get y. So there's a relationship there. Now, in this case, this would be a function because for every x value I plug in, I'm only ever going to get out one y value. And that won't be the case for every equation. We'll talk about that in a little bit. But for the most part, for right now, you just need to know that you can represent functions using equations as long as each input that you put in only has one output. So another example would be something like y equals x squared plus 4. Y equals 3 to the x to the third minus 5. So these are just different examples that would be functions, and basically the equation is like the rule. It's telling me what do I do to my input to get my output. So another way to represent functions or relationships is by using tables. So for example, in a table, if you have an XY table, this would show you the relationship between X and Y, or what X's and Y's go together. So if you want to determine a table of values, if it's a function or not, or if those table of values represent a function, what you would need to do is you would need to check each x value and make sure that it's only going to one y value. So basically you can't have any repeated x values over here that are going to different y values. So we'll look at some examples like that. The next thing is a mapping. So we looked at mappings in the first lesson. Mappings mean you have one set of elements and then you have another set of elements, which is the output values, and you show how each of these inputs gets mapped to outputs. So in order for this relationship to actually be a function, you have to check the inputs and make sure that there's only one, that each input is only getting mapped to one output. So basically there has to be just one line coming off each of these in order for it to be a function. The next thing are ordered pairs. So you can represent relations and functions using ordered pairs. So when we list ordered pairs, we list them in the curly brackets to represent the set of elements. And basically, these are just like your x comma y's. So x1, y1, and these would just be different numbers. So I'm just going to leave them as variables though, because they can represent any numbers. So this just gives you some scenarios. So obviously you can have as many ordered pairs as you want, but just to give you an idea. So if I want to check to see if this relationship is a function, what I need to do is I need to make sure that each of these x values is different. Because if I have repeated x values, that means I have one input. So let's say this is 1 and 1. I have one input that's going to have multiple y values. Now, that's of course assuming that the y values are different. In some cases, they might list the same coordinate twice, so it would still be a function. But otherwise, as long as you have x values that are repeated, that means you have one input with multiple outputs. And we'll look at number examples, but this is just to kind of show you the representation. And then the last type of way to represent a relationship or a function is just by graphing it and seeing the relationship. So when we look on a graph, we're looking at, does each of these x values only go to one y value? So it can only have one y value in order to be a function. So let's look at some examples and just evaluating different relationships in these different formats to see are they functions. So first thing we're going to do is we're going to decide, is the relation a function? Then we're going to state the domain and range. Even if it's not a function, you can still have inputs and outputs for relations. So we're going to go ahead and state domain and range for all of these different things. So the first thing I'm looking at is a table of ordered pairs. So we have two examples. In this example, I have, basically think of it as if your input's 1, your output's 5. If your input's 2, your output's 5. 3, the output's 5. 4, the output's 5. So basically all of these inputs are going to the same output. They're all going to an output of 5, but individually speaking, 1 only has one output. 2 only has one output. So each of these inputs is only going to one thing. So yes, this is a function. So yes, because each input has one output. So then the domain of this, all of the inputs, so all of the x values, so we can just list them out since we only have 4 of them. And then the range, well, we have 5, we could list it 4 times or just list it once since it's the same thing. So looking at this example, now basically what I have is I have 5 is going to 1, 5 is going to 2, 5 is going to 3, 5 is going to 4. So this is basically the same thing as if I were to write this as a mapping. 5 is going to all 4 of these. So this input has multiple outputs, which means this cannot be a function. So even though it's listed multiple times, it's the same thing as saying when x equals 5, there's 4 different possible y values, so that's why it's not a function. So this would be no, because 5 has multiple outputs. So the domain, the only input we have, even though this isn't a function, the only input would be 5, and then the possible outputs for this relation are 1, 2, 3, and 4. So let's look at the next example, which is going to be looking at ordered pairs. So looking at these sets of ordered pairs, remember you're looking for inputs here and how many outputs do they have. So the easiest way is just to scan and look at all of your x's. Here, all of my x values are different, so it doesn't even matter what the y values are, because since I start with 4 different x values, that means that each input only has one output because there's only one of every input. So 0 is only going to go to one thing because there's only one x value of 0. 1's only going to go to one thing because there's no other x value with 1. So yes, this is a function because each of these inputs is only going to one output. So again, yes, because each input has one output. So basically there's no repeated x values. The x values are all different, so that's how I know that it has to be a function. So the domain, all of the x values here, so 0, 1, 3, 5. The range, it's best to do these in increasing order. That's the proper way to write this notation. So I'm going to start with 0, 1, and 3. And I don't need to write 3 twice because this is just representing that 3 is used. It doesn't matter how many times. And again, remember, it's okay that 3 is repeated because 1's going to get you 3 and 5's going to get you 3, which still satisfies the definition of each of these inputs only as one output. It doesn't matter that the outputs are the same. If you look at this next example, though, and you compare the x values, see how right here we have a 1 being used and a 1 being used. So in this scenario, I have the element 1 or the input 1, and 1 is going to 0, and 1 is also going to 3. So this one input has two different outputs, and it's easy to see because basically when you scan and you just look at the x values, if you ever see repeated x values, you got to check those y values. As long as they're different, that means that you have an input that has two different outputs. So that means one input is going to multiple outputs, means it can't be a function. So this is not a function because 1 has multiple outputs. We can still write our domain and range though. So I'm going to start with the smallest number, so -2 for the x value, 0 and 1. And then the range, smallest is going to be -5. Then we have 0, 1, and 3. So now let's look at the mappings. So remember mappings, you have a set of elements getting mapped to another. For me, this is the easiest way to determine if something's a function because you're looking for, do you have just one line coming off of each of the inputs? As long as you have one line coming off of each of the inputs, you have a function because each of these only has one output if there's only one line coming off. So this would be yes. It is a function because, again, each input has one output. So the domain, look at your x values. So 0, 1, 3, and 5 are your input values. And then your output values, 0, 1, and 3. And then for this one, because of this 1 is going to multiple things. So if I ask you what is the output when the input is 1, there's two different answers, which is why this is not a function. So I have no, this is not a function because 1 has two different outputs. So for the domain, we have -2, 1, and 0. And for the range, if you look, range is all of my output values. This this 1 here doesn't have an arrow going to it. The arrows here are going to 3. So since this doesn't have any arrows going to it, it's not going to be part of the range. So basically, there's nothing that's ever going to get that value. There's no input that'll ever get you that 1, so it wouldn't be part of the range. You would never have it if you don't have any input to get it as an output. So the range is only going to be -5, 0, and 3. And then last two here are looking at equations and graphs. I kind of just grouped it together because whenever you're looking at an equation, you really want to think of the graph to come up with, is it a function or not? So if you imagine I have this equation here, which is a line, hopefully you recognize that as y equals mx plus b. So here's my x, here's my y. My slope is 2, positive, so it'll be going up. Y-intercept's 8. So this line is going to look something, so let's just pretend that this is 8. It's going to look something like that. So basically what you're asking yourself, does each x value only have one y value? So as I move along this line and I take any x value, so let's pretend this is like -5. If I take -5, I'm only going to get out one y value. If I take -2, I get out one y value. If I take out 0, I get one y value. If I take out 3, I get one y value. So for any x value along this line, you're only ever going to have one output or one y value. So this would be a function because each x value, or you could say input, that's what we've been saying. So each x value has one y value. So think about when you plug in x into this equation, there's only one y value that you can ever get out. So the domain of this is going to be a little bit different. You can't list out every single number because this line has arrows. So that you can plug in any x value you want and you're going to get out a y value because this line goes on forever. So to represent that, we're going to use negative infinity to positive infinity. And we put it in these round brackets, the interval notation, to represent all the way from negative infinity all the way to positive infinity. The range is the y value. So you're kind of looking, starting at the bottom of the y-axis and going up, what y values are included. Well, you can include every single y value. This is a line, so it's going to keep getting smaller and it's going to keep getting larger in terms of y. So the range is also going to be negative infinity to positive infinity. This just keeps on going. When we look at this next graph, though, we have a graph of a circle. So I already graphed this, so this is like our x and our y. This is an equation of a circle, x squared plus y squared equals 16. If you remember anything about graphing circles, the center of this circle is at 0 because there's no numbers after x squared and y squared. The radius is going to be 4 because you square root 16. So this point is at 4, this is at 4, negative 4, and negative 4 because this distance is all 4. So what we have to ask ourselves is this a function? So let's pretend I consider x equals 4. So x equals 4, there's only one y value, the y value is 0. But let's pretend I consider this x value of 3. So at that point, there's a y value up here, and there's a y value down here. So that means for this one input, I have two outputs. So that tells me it's not a function. I could also do the same thing over here. Let's say I start with negative 1. At x equals negative 1, I have this y value, and I have this y value. So I, again, have another x value with multiple outputs. So basically, this is not a function. So this is not a function because some x values, not all of them, but some of them, have multiple y values. So this is not a function. Now, if you notice, there's something down here at the bottom of the screen called the vertical line test. The vertical line test just means if you can draw a vertical line, so if you look, I could draw a vertical line and it crosses in these two places. I could draw a vertical line through these points and the line crosses my graph in these two places. So in this graph, my vertical line crosses twice, where if I draw any vertical line in this graph, it only ever hits in one spot. So, and that was a function, and this is not a function. So basically, the vertical line test is a shortcut. Instead of having to go through and think about, does each x value only have one y value, it's just a shortcut. So if you can draw a vertical line through a function and it only hits one time, or if you can draw a vertical line anywhere through a relation and it only hits one time, that means that that relation is a function. If you draw a line through, any vertical line through, and it hits more than once, so meaning 2 or more times, then it would not be a function. So that's what the vertical line test says. So let's go ahead and write that. So if any vertical line, so if I can just find one vertical line, so if any vertical line passes through the graph more than once, then the relation is not a function. So your vertical line can only hit once in order for it to be a function. And it can only hit once anywhere. So you can't have one vertical line that hits twice and consider it a function. As soon as it hits more than once, it's not a function. So let's just go back and finish the domain for this graph, and then we'll be done. So looking at the domain and range, so the domain, what x value? So now imagine going back to this orange circle. The smallest x value that you're ever going to be able to plug in is going to be -4, because that's where the graph starts. So it's going to be -4, but we can include it, so that's where these hard brackets come back into play. And I can include every x value, including decimals. So I don't want to list these out as whole numbers or integer values. I need to include decimals, so it's going to go all the way to +4. And then when you look for the range is all of the outputs, so all of the y values. So go from the bottom of your y-axis. It starts down at -4, and it stops for y values up at 4. So the range is going to be -4 to 4 as well. So those are the only y values that you could get out. These are the only x values that you can plug in. So why don't you go ahead, pause the video, and if you look at the next couple of pages, there's 10 quick multiple choice questions that just relate to are these functions or not. So pause the video, take a couple minutes, do the problems, and then you're going to hit pause, and I will go through these quickly so that you can check your answers. So go ahead and pause it, and then you'll be back to go through the answers. Okay, so going through these practice problems, so hopefully you actually did them. Quickly, we're just some different multiple choice questions. So which of the relations below is a function? So whenever you're looking at it with ordered pairs, you're looking for that repeated x value. So here, all of my x values are the same except for the 2's. So that's not a function because I have one input with two different outputs. Here I have 2, 3, 5, 6, 7. So I have all different x values. So this is going to be the one that is a function. The last choice couldn't have worked because I have the 3's that are repeating with two different outputs. For number 2, the answer should have been choice 4 because you're trying to figure out which x value will make this relation a function. If you plug in 7, then this will be an issue. And if you plug in 9, then this will be an issue because then you would have two inputs, two of the same inputs, basically meaning that one input has multiple outputs. So 4 would work to create this, so it would be a function. Number 3, the answer is false because if you look, this relation is not a function because we have 5. So 5 has two different outputs, 3 and 6, so it violates the definition of a function. For this one here, which of the relations below is a function, that would be choice 1, or the first choice here. These ones, you have 2 going to multiple outputs, and in this one you have 0 going to multiple outputs. So you have the x values repeating. Remember, you're not looking at the y values. You don't care if all of the inputs are going to the same output. It's just that each input can only have one thing that it's going to. Number 5, so whenever it's a graph, you're looking at that vertical line test. This does not pass the vertical line test. It hits in more than one spot. If I draw vertical lines through any of those, it hits in 2 spots, so it is not a function. This one here is a tricky one because if you look, you see, oh, we have repeated x values. 3 is listed twice, but you have to be careful because 3 is going to 10. So really, this is kind of like a trick question. They listed it twice, but this one doesn't even really count because 3 is going to 10, 3 is going to 10. So it's the exact same thing. So this one is actually going to still be a function because both 3's go to the same y value. So this is the case where you really have to be careful with just checking the x values, because even if they're repeated, you have to make sure that the y values are different so that you have one input going to different outputs. This one would be a function. This is a parabola because any vertical line you draw, it's only going to hit once, so that is a function. This one, number 8, is the relation a function? Yes, it is, because here we have all different x values. So each input only has one output. Even though they all have the same output, each of them only goes to one thing. This is not a function because many times it fails the vertical line test. There's several vertical lines where it would cross more than once, so no, not a function. And last but not least, is this a function? Yes, it is. Any lines are going to be functions because if you draw any vertical lines, they're only going to ever hit once. So hopefully you got almost all of those right, if not all of them. And that's it for basically determining if things are functions or not.